Hi everyone, today we're going to talk about characteristics of lines. So the first thing that we want to talk about is slope. And recall that there are various ways to think about or calculate slope. And the first one is using that idea of rise over run. And just as like a side note, rise over run is basically if you have an ordered pair here and an ordered pair here, the way that we could think about slope from the graph is by counting how many we are going vertically versus how many we are going horizontally. And that is generally called rise over run. Or if we don't have a graph and we have a t-table or input-output table, we could also do it from the graph, but we can use the slope formula that we have talked about before, y2 minus y1 over x2 minus x1. And then the last way is you'll also hear slope referenced as the constant rate of change or the change in y over the change in x. So let's talk about some different scenarios or examples here. One of the cases that we have are horizontal lines. And horizontal lines will always be of the form y equals 0x plus b. But note that 0 times a number is just going to be 0. And so really, the simplified version of that equation is just y equals b, where b is some number. And so anytime you have an equation that looks like y equals b, it's just going to give you a horizontal line, like you can see in this graph here. So maybe write yourself a note about how you will remember that. One way that I like to think about it is if you take two ordered pairs on this line, so let's say I took an ordered pair here and an ordered pair here, if I wanted to think about the rise over the run, because it's a horizontal line, I'm not moving up or down any units. And so the rise is going to be 0. And then if I'm counting how many I'm going over, that's 1, 2 units. So 0 over 2. And whenever we have a fraction where the numerator is 0, that just ends up being 0. And so that's how we can kind of see the slope in this horizontal line example. So go ahead and write yourself a note about how you will remember this in your own words. Our next case or scenario is when we have vertical lines. So, sorry, this is a mistake. That should say vertical. So vertical lines will always be of the form x equals a, where a is a real number. Notice that this equation is not of the same form as standard slope-intercept form. And we'll talk about why that is in a minute. Because generally, slope-intercept form is y equals mx plus b. And in this scenario, the equation is looking like x equals some number a. And so those don't quite look the same. And the part of the reason is that if we tried to figure out the m value, there really is no slope in this scenario. So let's think about why that is. Let's calculate the slope of this example using the formula y2 minus y1 over x2 minus x1. So let's maybe call this one x1, this one y1, and this one x2, and that one y2. So if we plug in those values, we'll get 4 minus 3 over 2 minus 2. And if we simplify that, we get 1 divided by 0. And you've probably heard in a math class or somewhere before that you can't divide by 0, and we say that this is undefined. And so this is illustrating why there's no slope in this scenario. And if you wanted to write the equation for this specific line, the equation for this line would be x equals 2. because notice that all of the ordered pairs have an x value of 2. So we've already tried to calculate the slope, and we've found that it's undefined. Now, here's the next scenario that we are looking at, and that's parallel lines. So what do you notice about these two lines that are graphed here? Take a minute to think about that. So it gives us the equations of these two lines here. Y equals negative 3 halves x plus 1, and y equals negative 3 halves x plus 7. What do you notice about these two lines? If you said that they have the same slope, then you are correct. What do you wonder? So I'll leave it to you to fill out these two questions, but hopefully you've come to realize that if you look at this graph, these two lines are not crossing or intersecting each other, and it just so happens that parallel lines will never intersect or cross each other. Okay, the next scenario is if we're dealing with perpendicular lines, and perpendicular lines mean that the lines given are exactly 90 degrees or at right angles to each other. So if you've never seen this symbol before, this little box thing where the lines are intersecting, that indicates that that is a 90-degree angle. Again, the slope will be a critical aspect of noting if the lines are perpendicular or not. What do you notice about this graph? So this one is different from parallel lines because they are intersecting at exactly one point, and the point at which they intersect forms a 90-degree angle. So one thing that we want to highlight is here's the equation of the first line and here's the equation of the second line. What do you notice about the slopes? Take a minute to think about that. Maybe pause the video. What's different about these slopes or how they're related to each other is that they are what we call opposite reciprocals. That just means that they have the opposite sign. So one of them is positive and one of them is negative. And reciprocals are when you reverse the numerator and the denominator. So one of them has the slope 3 over 1, which is the same as just 3. And the reciprocal is if we flip the numerator and the denominator to be 1/3. So these are called reciprocals. Okay. So down below, we have these two challenge questions. I'm going to let you all think about these on your own time, and hopefully you can fill these in and get the answers. Notice that the answer is at the bottom. And if you have trouble coming up with the correct answer, go ahead and talk to your instructor, and you can visit them in office hours or maybe ask them in class. All right.